Hello everyone, my name is Abhishek and welcome back to my channel. This is the very first episode of Observability Zero to Hero series, and in this video we will learn about the fundamentals of observability. So this is a very important episode. Make sure you watch this video till the end. Now, because this is the very first episode of the Observability Zero to Hero series, let me take a couple of minutes to explain the course syllabus and where can you get the notes for each episode of the series. If you go to this GitHub repository called Observability Zero to Hero, you will find the link in the description as well as pinned comment. Once you head here, you can see a README file which explains the complete course syllabus. So this is going to be a 7-day observability tutorial series where in each episode we will cover a concept of observability. Starting with today, that is day 1, where we will learn about the fundamentals of observability, such as what is observability, why do you need observability, what are 3 pillars of observability, how observability is different from monitoring, and what tools are we going to cover in this series. Then in day 2, that is the next episode, we will learn about the monitoring part where we will use Prometheus. So what is Prometheus? The architecture of Prometheus, how to install, set up and configure Prometheus on a EKS cluster. Along with that, we will also learn how to use Prometheus as a data source in Grafana, and we will play around with few dashboards. So this is going to be theory and practical, and from day 2, all the episodes are going to be theory plus practical. Then in day 3, we will move towards little advanced concept of Prometheus, where we will learn about PromQL, Prometheus query language. We will understand how to write basic PromQL queries, advanced PromQL queries, how do you scrape the metrics, what kind of information you can get from PromQL, that is the Prometheus query language. In day 4, we will head towards even more advanced concept of Prometheus, that is how do you instrument custom metrics. So for that, we will learn about Prom client library, which is the Prometheus client library, using which how can you scrape the custom metrics, how can you define custom metrics. Along with that, we will also learn about alert manager. How can you alert to your Slack or send an alert to the Slack, email or other things. In day 5, we will move towards another pillar of observability, that is logging. So we will use EFK stack. Both ELK stack and EFK stack are very popular. We will use EFK stack, that is Elasticsearch, FluentBit and Kibana. So we will learn how to do the aggregation of logs as well as visualization of logs. In day 6, we will cover another pillar of observability, that is tracing. So you will learn what is tracing, what exactly is distributed tracing, about some concepts like open telemetry. So whichever programming language you are using, there is a concept called open telemetry, which is bunch of APIs and SDKs, which will help you instrument traces, metrics, as well as logs. So we will also learn a little bit about open telemetry and we will play with Jaeger. So these are 6 episodes, and the final episode, apart from the 3 pillars of observability, we will also learn about eBPF in this series. So I'll explain what is eBPF, how eBPF is revolutionizing the space of observability over the last couple of years, and we will learn the advantages of using eBPF in your observability stack. So these are going to be the 7 episodes in which you will learn observability. Even if you are a beginner to observability, if you have knowledge of Kubernetes, basic knowledge of Kubernetes, you can learn observability. Because overall, we are going to learn observability on Kubernetes. Okay, now Abhishek, where can I get notes of this series? So you don't have to go to any other place. The notes is shared in the GitHub repository. You don't need to download it from internet, or you don't need to go to the Telegram channel. The complete notes right from day 1 to day 7 is shared in the day-wise folders. You can go to a particular day. Let's say you go to day 4 and you can see the complete theory part that is explained in day 4, along with architecture diagrams, images, and not only that, you will also see the scripts used in the video as well as any YAML manifests. So you will get the complete copy of what is explained in the video. After watching the video, any particular episode, you can go to these notes and use it as revision material. So that's all about the core syllabus as well as the notes. Now let's move to the first topic of this series. What is observability and why do you need observability? Let's start with these things first. The textbook definition of observability says if you have observability setup, you can get the information about the internal state of the system. So what is system here? It is basically your application along with the infrastructure required by your application and the networking. So the definition of observability says if you have observability in place, you can understand the state of your application. Is it working as expected, or are there any failures? You can understand the state of your infrastructure, and you can also understand the state of your networking. Maybe something like the latency or the HTTP traffic, all those things. Let me give you some examples so that you can understand the definition better. If you have observability in place, you can get the information like what is the disk utilization of a particular node on my Kubernetes cluster over the last 24 hours. Why do you need this? Because you want to understand if the disk utilization is 100% at any point of time, or is it constantly 90%, or is the disk underutilized? Maybe if it is only 20% all the time. And you can also get information like what is the CPU utilization of a particular node of the Kubernetes cluster. Because if the CPU is 100% utilized, your system does not perform better. If the CPU is only utilized 10% all the time, then you need to reduce the CPU on your node because you are wasting a lot of resources, wasting a lot of money. Similarly, it can be memory. What is the memory utilization? Not only the utilization things, but you can also get the things like out of 100 HTTP requests or out of 100 API calls that are made to my application, what is the number of requests that were successful? What is the number of requests that were failure? You can also get this information. So this is all the what part of observability. So using observability, you can get information like what is the state of my system. It can be the disk utilization, CPU utilization, memory utilization, or even the number of HTTP requests that are failed or passed. But observability does not stop here. It will not only tell you what is the state of your system, but it will also help you understand why is your system in that particular state. So using observability, you can understand out of 1000 HTTP requests, let's say if 5 are failure, you can also understand why the 5 HTTP requests have failed. What is the reason for it? In which part of the application the request is failing? You can get complete information about the failure. Also, you can understand why there is a memory leak, which is causing extra memory usage by a particular application. And observability can also help you with how to fix these issues. So observability can help you with understanding what is the state of the system, where you can see if there are any issues with the system. It can also help you with why your system is in this particular state, and you can also understand how to fix it. How to fix the 5 HTTP requests that are failing. So you can get the complete traces of these HTTP requests, how the HTTP request has passed through the load balancer, when did it reach your front end application, then back end, then to the database, where exactly is the HTTP request failing. Once you get that information, you can fix the particular request. Same happens with the memory leak as well. If an application is using more amount of memory, using these traces, you can understand which part of the application is using memory extensively and how to fix it. So using these three concepts, what, why, and how, observability becomes very, very robust. But Abhishek, how can observability do so many things? So there are three pillars of observability. As you can see, the first pillar is metrics. The second pillar is logging. And the third pillar is traces. So metrics, logs, and traces. If you have set up metrics, logs, and traces for your application, and if you have the applications in place for tracking the metrics, logging, and tracing, you have set up observability. So the metrics part is basically responsible for understanding what is the state of your system, whereas the logging part is responsible for understanding why is your system in this particular state, and the traces can help you understand how to fix the particular state. If you take the same example, let's say a HTTP request or a API call to the application is failing. If you take this as an example, using the metrics, you can understand that, okay, a HTTP request is failing, and over the last 30 minutes, 10 HTTP requests failed. Over the last 24 hours, 100 HTTP requests failed. You can get this historical data using metrics. Whereas coming to the logging, you can pick up one HTTP request using this historical data. You can identify the timestamp. Okay, at 10 o'clock, a particular request has failed. So you can go to the logs of that particular application. You can see what happened at 10 o'clock, who sent the HTTP request, to which part of the application did that HTTP request hit, and why exactly is that HTTP request failing. Then you have traces, where traces is a very interesting concept. It can help you with the complete HTTP request tracing. That is right from the point of client. So client has sent a request to the load balancer. From load balancer, the request went to the front end. From front end, it went to the backend, and from backend, it went to the database. So using traces, you can understand how the request went to the load balancer. From load balancer, did it go to the front end? If it go, how much time did it take? Did it take 5 milliseconds? Is it expected or not? From front end to the back end, again, how much time did it take? Did it actually go to the back end? If it go, how much time it took at the back end? And to which backend did it go? Did it go to the expected backend or any other backend that is configured? And finally, if the request went to the database, all this tracing information can be taken care using the traces. So it can also help you with how to fix the issue. So what, why, and how are covered by metrics, logs, as well as traces. So if you learn metrics, logs, as well as traces, you know the complete observability. Now the big question is, Abhishek, is this responsibility of a developer or DevOps engineer? Is observability taken care by developers or DevOps engineers? We will learn this towards the end of the video. Don't worry. But right now, let's focus more on metrics, logs, and traces. Like Abhishek, can you explain in little bit more detail what exactly is metrics? Sure. So metrics basically gives you historical data of the events. So if you take any particular event, so the event can be the CPU or memory utilization or disk utilization, or it can be the HTTP request, right? These are all the events. So using metrics, you can get the historical data of the events. That means over last 30 minutes, let's say, what is the state of the CPU? What is the state of the memory? What is the state of the disk? What is the state of the HTTP request? So you can track all that historical information using metrics. This will help you understand if the CPU is overutilized, underutilized, partially. That means once in an hour or at a particular time of the day. If your CPU utilization is at its peak, sometimes you might see that throughout the day, the CPU utilization is very normal. But at one point of the day, the CPU utilization went to its peak and then again it is back to normal. Assume this is causing some issue with your application. How would you understand if you don't have historical data? If you just have the current data, current state of the application, you can never understand why your application went down at 10 a.m. in the morning today or 10 a.m. in the morning 10 days ago. If you don't have this historical data, there is no way you understand what is the issue. So for that, you need metrics. It gives you historical data of all such events. Now the next thing is logs. I think many of you are familiar with logs already. So logs basically helps you understand your application better. If a developer is setting up proper logging for the application, there are different types of logs, right? You have info log, you have debug log, you have error log, trace logging. So there are different types of the logs. So if a developer is logging these things, or if a developer is instrumenting these logs, you can understand your application better. So at 10 a.m. in the morning, using the historical data, you understood your application went down. That is, CPU utilization is high. You can go to the logs of that particular application. You can go to 10 a.m. logs and you can see which request was sent at 10 a.m. And in the logs, you can see which part of the application, which package of the application, which module of the application was hit during that time. And that will give you information that, okay, so this is why the CPU utilization was high, or this is why the memory utilization was high, because the part of the application that the HTTP request hit is leaking memory, right? So logs will help you understand furthermore about what is issue. Finally, like I said, you the traces part. I think I have explained the traces part very clear here. If you have traces along with the logs, so logs will give you some amount of information. Traces will give you extensive information to debug, troubleshoot, as well as fix your issue. Now, a big question that people have is, Abhishek, what is the difference between monitoring and observability? Are they the same things? Like, people ask for monitoring in the interviews. Is monitoring same as observability or is it different? Let me tell you, out of three pillars of observability, that is metrics, logs, and traces, monitoring only focuses on one pillar of observability, that is metrics. Along with metrics, if you have alerts and if you set up dashboard, that is basically monitoring. So monitoring only covers one pillar of observability, that is metrics. Along with metrics, it will also implement alerts as well as dashboards. So when you say a application with perfect monitoring, you need to have the historical data of the application. That is, you need to have the metrics. Then if the metrics are reaching a particular point, if CPU is reaching 80%, then you can send alerts either through Slack or email, or let's say any other platform that you are using. And you can also record this information in dashboards like Grafana. So we will cover the complete monitoring. We will not only cover metrics, but we will cover the complete monitoring in this series. You will learn metrics, you will learn alerts, and you will also learn how to see the dashboards on Grafana platform. So monitoring and observability, they are not same. Monitoring is a sub part of observability. Observability is a whole thing where you can get the feedback of your complete system. Abhishek, can you explain an example like in real time? Why does a company need all this information? Like if there is an issue in production, they can immediately react on the issue, right? Why do they need to spend so much amount on observability to get all of these insights? Let's take a practical example so that you people can understand. So assume you're working in an organization. Let's say this is a product based company. So this is a real time use case that I'm explaining. So you're working in a startup where the startup has built, let's say, a application like resume builder. So this is their application, and you have deployed this application on a Kubernetes cluster on the AWS infrastructure, and you have set it up with a proper networking, let's say within a virtual private cloud. Now, once this everything is done, like your application is built, you have deployed it on Kubernetes, you have AWS, the next goal would be to search for customers, right? You need customers, you need to sell the product to the customers. So you would look around for the customers, or your organization would look around for the customers. And quite obviously, when you find a potential customer, the customer will say that there are other resume builders in the market? Why should I go with your resume builder? My employees can use any other resume builder. So you would tell the customer, okay, look at our service level agreement. So if you are not from SRE background, so service level agreement, you can understand as a basic agreement. So your organization will tell the customer, we can sign a service level agreement with you, where in the agreement, we will define some objectives. Basically, you will make some promises to the customer. Objectives are nothing but the promises that you are making. Like what? You will tell the customer that 99.9% of time, my platform will be available. That is, my resume builder application, there is only chance of 0.1% of it going down throughout the year. Or another objective that you write to impress your customer is, out of 10,000 requests that are sent to our resume builder, at least 99,995 requests respond back in 30 milliseconds, and that too with 200 HTTP status code. That is, out of 10,000 HTTP requests, 99,995 requests respond back in 30 milliseconds with success code. So your customer, the potential customer, if they are impressed, they will take the subscription of your resume builder and your organization is happy. But is everything done? No. This is where the actual thing starts. So you have signed multiple SLAs with different customers and you have promised some very strong objectives. How do you make sure that you are meeting the expectations of your customer? You don't want your customer to come back and say, hey, your service level objectives are not met, or the promises that you made are not fulfilled. Even before that, you need a continuous feedback system in your organization. So let's say you promised for 99,995 requests to be responded back in quick time. You need a feedback system where this feedback system, even if one request is failing, because you just have a error budget of 5 requests. So even if one request or 2 requests or 3 requests are not meeting the expectation, you immediately need to take an action. So you need a system that gives complete feedback about the internal state, and that is observability. So in these cases, a strong observability platform is required so that you can get complete information about what is the state of the system. Is the state meeting the expectation of service level objectives that I've signed with my customer? If part of the requests are failing, like let's say 3 requests are failing, why are they failing? Because right now they are 3, which is fine. But if 5 requests are failing, one of your objective is not met, then your organization will have a problem. And immediately you need a feedback, like how to address that, how to immediately fix it, so that we don't reach to a point where 10 requests are failing or 15 requests are failing. Immediately, if 1, 2, or 3 requests are failing, if you take action, you will not go to a state where 5 requests are failing and you fail your customer promise. So this is a real-time use case of observability. Typically, companies with strong SRE principles. So if a company needs SRE, the first thing that they have to do is they have to implement observability. So Abhishek, is it only required for such companies? No. Even for companies like Instagram or companies like Facebook, these days, every modern application needs observability, because when you have end users, it can be even a banking application, can a banking application, will it be fine if 5 users are facing an issue? No. Will it be fine if the request to the banking application is taking a lot of time? They would be fine if the request by a particular user is taking 5 seconds, let's say, or they would be fine if the request is taking 10 seconds. But if the request is taking 20 seconds, they would not be fine. So immediately, if the request is taking more than 5 seconds, the observability system should alert the developers of that banking software so that it will not move from 5 to 10, 5 to 10, 10 to 20. Okay, now I think you might have got understanding of observability and how it will help the organizations. Now the final thing is it a developer's responsibility or is it a DevOps engineer responsibility? So there is a long debate like observability has to be implemented by the developers or is it by the DevOps engineers? Is it by the SRE engineers? Let me tell you, observability is always a collective effort. There is no way only the developers or only the SRE engineers, only the DevOps engineers can implement observability. If you understand it carefully, there are two primary parts, right? So the first part is that whenever you have your application along with your infrastructure and networking, the first thing is your application should instrument the metrics. That is, your application should throw some metrics or your application should instrument the logs. The developers of the application should actually write the info logs, debug logs, error logs, any other logs. And the developers of the application, they should also implement the traces. So if the developers are not instrumenting or implementing the metrics, logs, or the traces, there is no way the DevOps engineers or the SRE engineers, they might use the tools like Prometheus, or they might use strong tools like ELK stack or anything like Jaeger. But nothing is going to happen if the developers are not instrumenting these things. These things are fed to the platform, right? Metrics are fed to Prometheus, or Prometheus will look for the metrics. ELK stack would look for the logs. Distributed tracing platforms would look for the traces. If these are missing, these platforms cannot do anything. Similarly, if you have metrics, logs, and traces set up by your developer, I mean, instrumented by your developer, but you don't have these applications deployed on your Kubernetes cluster, again, there is no use. So it is a collective effort where developers will instrument the metrics, logs, and traces, and DevOps engineers will do the implementation part. So they will set up the monitoring stack, they will set up the logging stack, the distributed tracing, so that for end users, it can be your management, it can be your QE, or it can be any other team. Even it can be developers, they can look at the platform. Like once you have ELK stack setup, let's say, so they can use the logging stack to query a particular error over the different applications. So it is a collective effort. In this series, we will learn from DevOps and SRE engineers point of view. How do you install, set up, and configure these things? Along with that, we will also cover some part from the developer's point of view, where we will see like using open telemetry. How can developers instrument the metrics, traces, and logs? Because open telemetry is the popular CNCF platform. It is collection of APIs and SDKs. This is not a single utility or a tool. Basically, open telemetry is the group of APIs and SDKs which can help the developers get these things, like instrument these things. So we will also learn that also using Prom client, which is for Prometheus, specific to Prometheus, we will see how developers can scrape the metrics. So These things will be covered in the series. I hope you found today's video informative. Let me know in the comment section. Did you find it useful? Are you excited for this series? Going ahead, we will do theory plus practical of each of the concepts that we have learned in today's video. See you all in the next one. Take care. Bye bye.